right, welcome back. You just missed it. I got a nice little tongue thrashing to my second block class, and third block is going to get theirs later. If I could record those and put them online, I would. I'd get more subscribers. Don't forget to hit subscribe, hit the like, hit the bell. Okay, so nth roots. Okay, believe it or not, this stuff is easy if you don't have your head in your fourth point of contact. Okay, it's what you are sitting on. Now, here's the deal. If we have something like this, some nth root, squared, cubed, fifth, 80th, we can actually write it as a fraction like that. Okay. Now, also, we have something right here. This is what I like to call, this is in the gutter. This is going to be always going to be our root. And this is going to be our power. Okay. Root, power and root. Okay. So now that's our definitions. That's actually pretty simplistic. Don't try to change what it says. Okay. Don't try to interpret it like it's some mythological mystic thing. That's it. Okay. So anyways, the direction says write each example in radical form, then simplify if possible. Now, I want to also explain something to you. These directions you see on your practice test, pre-practice test, and test, they're usually taken from the notes. Okay, so this right here, I know I'm going to have a radical. I can put a 2 right here. This is 36 to the first. Okay, that's how you would write it in radical form. Now, can we take the square root of 36? Yeah, okay, finally. Yes, we can. It is 6. Yes, the use of calculators are encouraged. All right. So, number 2. Remember, this is our root. That's our power. So we're going to have the square root of 4 to the 5th. Now, couple of things. You could actually enter this into the calculator as it's stated, or you could do it in radical form. It doesn't matter. You could take the square root of 4 raised to the root 5th. It would look just like that, and we would get our answer. Yep. Very simplistic. Now, on this next one, the parentheses are important. Just kind of like when people were trying to do the easy part on the back where you just plug in that number. They're like, why does Mr. Jeffers always use parentheses? That might be a reason. All right. This is the cube root of 27x quantity squared. If you ever hear me say quantity, that means that it's actually holding it in the parentheses. That's everything, everything. Now, 27 squared is 729. Let's see if I can take the cube root of that. So 3 second raised to the roof, 729. I get 9. Okay, so I can actually take this and I can put 9 out here. Now, We would actually leave the x squared in here because it doesn't have enough power to come out. It cannot come out of the house and play because it's not up there enough. Okay? That's it. Now, so what is the only thing being raised to the power on number 4? B. So 18 would actually go, like I said, outside the house because it's not included right there. This is B to the 5th. Now, crazy thing, this should have actually possibly been covered in geometry, depends on who you had. All right, so this is the way you would do this. How many times will 3 go into 5? One time with a remainder of 2, right? So I would pull out 1b because it's all right. What was my remainder? B squared goes right there. So remember, all I did was divide 5 by 3. That's what this work is over here. All right. So that's how we would go from our rational exponent to radical form. Yes. Well, a couple of reasons why. I'm going to do it right here. All right, this is b to the 5th, right? Okay. So this can be rewritten as b times b times b times b times b, right? All right, these 3 would be able to come out because we're taking the cube root, right? Okay, so that's why that b got to come outside. How many b's are left inside? Okay, what I just got finished saying is because this is technically b to the 3rd, it's the cube root of that. Yeah. Okay. Now, now we have to do it in reverse. Okay. So we would have we know we're going to have our y right here because that's what's underneath the radical. What is the power that y has right here on number 5? 2, so it goes on top. What's the root? It goes in the bottom. That is our answer. All right. Now, this is the only thing that is dealt with the radical. So the 8 is going to be on the outside. I would put everything else in the parentheses. So what is this underneath this radical sign? X. What's its power? 1. The root is 3rd. So when we're done, it's x to the 1/3. You're fine. Yes. Isn't that what I have right here? I have 18b. Yeah, it's exactly the same. Okay, right here. Can we take the cube root of 64? Yeah, there's actually an example of that in this classroom. It is 4. It's on the board. Now, so how many times will 3 go into 7? 2 with a remainder of 1. So when we write this, this is going to be 4x squared cube root of x, and you could write it like that or to the first. It doesn't matter. Where do we get the squared from? Do you remember why I said how many times? Do you need to see it like this? Okay. So now, all right, when I'm saying the remainder, and I'm saying that it remains in the house, 3 goes into 7 2 times. That's why we were able to pull it out. It had a remainder of 1, so it stays inside the house. Okay. Now, this is everything to the 6th power. So I would do this part first. I would do 27 to the 6th power in my calculator, the cube root of it. Crazy. Look, and I even put it in my calculator with parentheses. I get an actual number, 729, because it multiplied 27 by itself 6 times, then took the cube root of that. I don't need to know what 27 to the 6th power is. All I need to know is what the cube root of 27 to the 6th power is. Okay, so I get 729. Now, with the x, how many times will 3 go into 6 with no remainder? Mm-hmm. Now, when I said this stuff is a little bit easier, it is. Okay? Now, should you grasp it entirely right now? No. Should you have a pretty good idea? Yes. If you grasp it entirely, that means that you paid attention, okay, didn't steal oxygen, and that was good. Now, we're going to skip the your turn right now because we have other things to do, and I can come back, and I don't want to record myself sitting here for 5 minutes as y'all struggle with these 8 problems. So, yeah, it was the yes, and that goes yes, that's fine. Okay, so As this says right here, this right here, this is the boring math definition. Okay? I just had to show it to you. This is the Mr. Jeffries definition. Find the indicated nth root of a. So this is what it's saying. If it says n is 3 and a is 216, what is the cube root of negative 216? Well, we plug it in the calculator. 3 second raised to the roof, negative 216. And yeah, we got a negative because think about it. That's an odd number of times you're multiplying a negative. So it's negative 6. Okay? This one right here. This n equals 4, a equals 81. What is the fourth root of 81? So kind of the same thing, except I hit 4 second, raise the roof, 81. I get 3. And that's it. Now, students in class are actually going to hopefully work on this. Now, there are some people that haven't even started, and then they're going to complain and try to cheat on the next test like they did the last 3. So we'll see how that goes. Stay tuned. I might give an update on that. All right. Don't forget, hit subscribe, hit the like, hit the bell. Good stuff, good things. Roll Tide.